How's it going? This is Dr. Schulman, and this video is going to be for Math for Teachers. I'm starting with just the intro to natural numbers. Everything you can find off of Delta, and it's free, which is cool. So if you want any, you should be practicing along and doing examples that you can't see. Now I'm gonna do a little intro of what the different types of numbers are. And then 1A had addition, subtraction, multiplication, division. So I decided to break that up into just doing adding and subtracting first, and then I'll do the other part too, because there's so many different ways they can show it and so many different ways you can teach it. So I'm going to share my screen. Here I am. I'm going to minimize the zoom. So right here, this is the information from your exam: natural numbers, whole numbers, integers, and rational numbers, right? And the first one is numbers and operations, which is what we're doing. And we need to know the algorithm, strategies, and models for problem-solving situations for adding, subtracting, multiplying, and dividing. I'm just going to do adding, subtracting first, because there's a lot. If you go into Math for Teachers, you click here, you're going to see this, and I'm going to put in all the examples right here. But first, I just want to talk about what these words mean, because we have to know the different types of numbers and where they come from, I think is important. Then we're going to go into Delta Math. And these are all the ones I'm planning to do today. I know that seems like a lot, right? There's like 30 problems I want you to try, but you can just click them and see the answers. So this is like where you can try them. But notice they're all just adding and subtracting. I try to go from easy to hard, and I got decimals in there. I got some fractions in there. But hopefully it's useful, right? Every possible way I could show it. These will be the problems that we cover. But first, what are these words? So let's really think about what these words mean. The first thing we want to do is talk about who came up with these numbers, the numbers that we use. So Al Khwarizmi. I'm terrible at spelling. Is that him? There he is. Let's look at the image for his numbers. And you should be showing your students. I feel like, all right, so here we go. Here's basically where they come from. So these are the numbers we're looking at. So, oops, sorry, I went a little too far. So one has one angle in it. Two has two angles. Three has three angles. Four has one, two, three, four angles. Five has five. Seven has one, two, three, four, five, six, seven. And zero has none. So if you ever have your students and they're struggling with their numbers, show them that they can be created by the angles that make them up, and maybe even teach them about the person who made it. So I think it's really important for students to see that. And there's a picture of our friend right here. Ta-da! There's a great picture of him. I'm pretty sure it's Al Khwarizmi. That's how I've always said it. All right, so let's really think about these numbers. Let's first start with why don't we start with, should we start with rational and go back? Why not? So we'll start with the hardest one. So what are rational numbers? Rational numbers. It doesn't have irrational, but I'll tell you that as well. That's fine. So what's a rational number? A rational number can be represented by like A over B. So it can be written as a fraction like 1/2 or 1/3. It could also be a whole number, because whole numbers can be fractions like 2, because that's really 2 over 1. Basically, what a rational number means, it's can be written this way, and the decimal stops, okay, or repeats. Okay, so what do I mean by that? So whenever they're talking about rational numbers, if I have 1/3, that's still rational because it's 0.3333333. Still rational because it could be represented that way. Is the number 4 rational? Yes. Is the number 5.2 rational? Yes. Well, what is irrational? You might think, well, irrational is something like pi, or something like tau, or something like Euler's number. These are basically decimals that go on forever with no repetition. Now, if I pull up a calculator and I hit the pi button, and forever. See how there's no real pattern, it just keeps continuing forever? That means it's irrational. Let's do Euler's number. And students like Euler's number because it's the money constant. Oh, and how do you get pi? You just take the circumference of a circle, the circumference, so the distance all the way around the circle, your circumference, you divide that by the diameter. Guess what that gives you? Pi for any shape. Euler's is the money number, 2.718, and it's used all the time for things that go on forever. So if we want to look at Euler's number, 2.718, you'll notice that it always comes in amount equals principal Euler to the RT. And this is for continuously compounded interest. So that's where that comes from. All right, so we did the first two. And let's do integers. I believe integers are whole numbers that could be positive or negative, but I always like double checking everything to make sure where we're doing this. So integers. Yep, integers is 0 is neither positive nor negative. So does an integer include 0? Let's see. Does integers include 0? Integers are a set of numbers that include all whole numbers, 0 and positive integers, as well as negative numbers. Integers do not include zeros or fractions. That's what I thought. But I just like to double check, especially when it is, when we're looking at definitions. So what is integer? An integer is everything on a number line that is a whole number, positive, negative, and includes 0. Ta-da! So when you're talking about integers, you can just show students a picture of a number line with 0 in the middle. 1, 2, 3, -1, -2, -3. Ta-da! So that's everything there. Nice. All right, whole numbers and natural numbers. Let's see. Whole number. Now we've got natural numbers. Nice, I like it. All right, so let's look at whole numbers versus natural numbers. All right, here's the difference. Natural numbers are all the positive ones, and whole numbers are all the positive ones, but with 0. Cool, I knew one had 0 and one didn't. So natural numbers is everything positive from 1 upwards. Whole numbers are just everything positive, but including 0. I like that. So whole numbers, and just to make sure everybody's on the same point, what's a good way to remember it? Whole has the 0. There's an O in whole. So that's the best way to remember this difference. So whole numbers includes 0 and all positive, all positive values with no decimals. And what is our natural numbers? So natural numbers are all positive values with no decimals. And because 0 is not positive nor negative, we can't use it. All right, cool. I hope that was useful. Rationals, A over B, it's a fraction that stops. Irrational are repeating decimals that go on forever. Integers are negative, positive, and zero. Natural are all positive with no decimals, and whole numbers are zero and positive. Cool. So that's the difference between these four things. And this is everything that we're going to be looking at. I'm throwing some decimals in here too, just because we're doing adding and subtracting, because why not? So here we go. So here's A. Well, it's A part 1, right? Because I'm going to do all these problems with just adding and subtracting. So I think we're ready. Now, if any of these get too crazy, I'll show you how great delta math is. Now, delta math will give us what? Answers, hints, things like this. I'd like you to try them. I'd like you to try whatever ones you're afraid of. And if I'm making you try them, guess what? I'm trying them myself. So here we go. Follow the steps to help you. So these are our base 10 blocks. I'm going to move my weird head. This doesn't have to float in our way. There we go. So 34 plus 56. Follow the steps below to guide you through a visual understanding of addition. How many total 10 rods would you need to represent this? All right, so they're giving us the answer is 111. That doesn't make sense because it doesn't even add up to 100. Oh, they just want to ask. Okay, so 6 and 4 is how many 10 rods will we need to represent this? So there's 3 here, 30. So we need 3 10 rods, and there's 5 for 50. So we need 8 of these. So we need 8 10 rods. And how many small 1 cubes do we need? We need 10 small 1 cubes. Well, let's try it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see if this is the right answer. Ta-da! So what is it? Well, we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 90. Are we sure? Yes. Cool. So that was the first one. I didn't have to write any math over here, but just remember that the blocks that look like this, these are 10, the little baby blocks. This is 1, and this really helps students. And then the big grids. Need one more. Okay, and this one's 100. Cool. Let's go to the next one. All right, time for the next one. Oh, we get to go to level 2. All right, so here it is. So we have 319 plus 911. Oh, so we have 1,000 block here too. Crazy. It's like a cube. So how many total 100 sheets will we need to represent? So that's 3 and 9. So that's 300s and 9. So that's 12. How many 10 rods do we need? Well, that's 1 and 1. So that's 2. And how many small ones do we need? That's 9 and 1. That's 10. We did it. All right, so how many hundreds do we need? 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many 10 blocks do we need? 2. And how many 1 blocks? 1, 2, 3, 5, 6, 7, 8, 10. This should be the answer. For 1 extra 1. Cool. So, and this is going to make 1,000, right? Nice. So we have 1,000. 200 and 10, 20, 30. We have 1,230. We got it right. Cool. Okay, so hopefully that was clear. 1 times 1,000, 2 times 100, 3 times 10, and we have no ones left over. And there's our solution. Sweet. Now, if you want, you can click new problem. It gives you another version of it. When we click this, we're scared, it shows us the exact solution, which is nice too. All right, let's go back. We're up to number 3. Now we get to do this with a decimal. All right, let's go. So I haven't needed the notes yet. Just if you're using these, the one that's like the crazy cube, this one's going to be 1,000. And you'll have these in your classroom. So follow the steps below to guide you through a visual understanding of an addition problem. So 0.26 plus 0.15. To represent 0.26 and 0.15, we would need 3 1/10ths. sheets and 11 1/10ths here. Oh, it's because it's already showing us the solution. My bad. We have to do the question. I'll do a new prompt. Sorry about that. All right, here we go. So follow the steps that's below to guide you through a visual understanding of an addition problem. How many total 1/10 sheets would you need to represent 0.25 and 6? So this is 1/10. So when we're talking about 1/10, we can visualize this as literally one of these blocks. This is how I visualize it. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is colored in. That's 1/10 to me. They're saying it's just one out of this 10 by 10 sheet. So this is how they're showing it for this one. So the 10th place is the second. So if you ever want to know, this is your ones place, this is your 10th place, this is your 100th place, this is your 1000th place if you get there. Okay. Just like the other way, that's the tens place. This is the hundreds place. So here's 2 plus 6. So we need 8 of these guys, which are these. And then we need how many of the baby ones? So this is 1 out of 100 because this is our 100 block. So it's 5 and 6. So we need 11 of these. All right, let's use them. So we need 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. And we need 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, let's see how I did. That should be one extra. Ta-da. So what is the correct answer? Well, let's think about this, right? We have to add these up. So it's going to be point. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, D1, 0.91. Let's see how we got it. Cool. All right, let's try the next one. So the next one is a base 10 blocks with decimal addition. Ooh, it's harder. Level 2. All right, so here we go. All right, so now we've got this is a whole one. Why is this a whole one? Because this is 100 blocks. So if this is 100 blocks, we take this away, we get one of them. Sorry, this is 1,000 blocks, so we take it away. We got one. There's the 10th, there's the 100th, and there's the 1,000th place. We got a baby 1,000th place. So how many 1/10 blocks do we need? 7 plus 9, that's 16. All right, how many little ones? Well, 9 plus 7. It's the same thing, 7 plus 9. Okay, I'm not going to argue with it. 16 of these. How many little ones? 2 plus 3 is 5. All right, let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yep. Now I need 16 of these. 1. Where are they? Oh, there. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then I need 5 of the baby ones. 1, 2, 3, 4, 5. And now I should combine these. Whoa. We need another combine. The magic is happening. All right, here we go. So we start with a whole. And I have 1, 2, 3, 4, 5, 6, 7. And I have how many of these? 1, 2, 3, 4, 5, 6. And how many of these do I have? I've got the 1, 2, 3, 4, 5. We did it. Cool. All right, let's keep it going for our addition. And we'll get to subtraction. All right, so that was all addition using the blocks. Let's do addition on a number line. Might as well. All right, here we go. So this module guides you through solving 22 plus 69 with an open number line. Add or take back values until you've added on to 69. You can only work with ones or tens. Use the table to track where you land once you've added the total. So this will be really helpful. So use the plus or minus button to add or take away. Okay, so let's try it. So we've got 22. We're going to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, wow. Whoa. So that's 60. So we got to add 60. So I want to add 69. Will it let me? Nope. Okay. So let's go to land at 80. So we're right now at 82. All right. That brought us to there. So we started at 22, landed at 82, and now we have to add how many more? So I started at 22, I added 60. Now how many more did I leave out? I got to add the 9 more. Cool. So that's going to bring us to 89, and I believe that is our final answer. Oh, sorry, no. 82 plus 9 is 91. My bad. We all make mistakes. So we totally added 69. Our final answer is what? 91. And the number line is really useful. So first we added the tens place. So we added the 60. So we're basically breaking up. So basically when we're adding the 69, we're basically adding 60 first because that's this piece. Then we're adding the 9 more. So we're taking the 22, we're adding 60. That brings us to 82. And then I add 9 more, gives us our final answer of 91. Ta-da! Add tens and then add ones. Or we could add 70 and subtract it. Ooh, I like that one. So these are a bunch of ways we can do it. Add tens first, add ones, add tens first, overshoot, and then go back one. I like that too. Either way, you're going to get the 91. I need some more space. All right, so we're up to 3-digit addition using the number line. All right, so this module will guide you through this. Okay, so we gotta add on 628. So let's start. Let's add, oh, sorry. Use the plus or minus to add or take back. So I'm trying to do. All right, so let's start with 600. And we're gonna land at 7. If I add 600 to this, I'm landing at 784. All right. Cool. So I added 600. So basically I'm taking 628. I'm adding 600. Then I'm going to add 20. Then I'm going to add 8. I got to add 20. And this is going to be 804. Let's try that. You must plus sign or add. Oh, sorry. So I added 600. I got to add 20. Oh, I didn't hit the plus. Oh, I have to hit the plus. That's fine. So that's going to be 804. Let's try it. Nice. All right, and now we have how many left over? We have 8 left over. So I have to do 8 plus. So it's going to be 812 is our final answer. So our answer is going to be what? 812. Thank you, number line. Ta-da! Okay, so we could even do the 30 and overshoot it. I don't like the subtraction, but this is the way I did. Oh, we can go 6. We can do the little part first, then add 10. Okay, so we can add 6 to go to 190, 10 to go to 200, 600 to go to 800, 10 to go to 810, and 2 more to go to 812. I like this. So this is going to whole numbers first, all numbers that end in 0. I like that method. Either way, we got the same answer. So you can add big numbers, you can add and then backtrack, and you can add tens at a time. All right, let's keep it going. All right, so here's some decimals. We're using the number line still, but now we're working with decimals, which shouldn't be too crazy, okay? So here we go. Here's the first one. We're gonna add, we gotta add 10 first. So if I add 10, so basically I'm taking this 0.19, I'm gonna add 10, or 0.10, and then I'm gonna add 0.09. So this is gonna bring me to 0.79. And then I have to add 9 more. 0.0, well, okay. Oops, 9 more. And so what is 0.79 plus 0.09? That is 0.88. Ta-da! We added the whole 0.19. We're left with 0.88. Ta-da! So this is the way that I didn't do it this way. They added the 0.01, made a whole number, then they added it, which is fine. So 0.01 to get to 0.7, 1 to get to 8, then 8 more. And I didn't do it this way. Oh, I guess I did do it this way. Sorry, it's a little confusing seeing all three at the same time. All right, what do we got next? All right, so here's addition, open on a number line again. Okay, here we go. We got some big numbers. So I'm going to add 56.6. And you can show students a number of ways to do it. That's why the answers have them all. But at first, I'm going to add 50. And then I'm going to add 6. And then I'm going to add 0.6. That's how I'm going to do it. So let's add 50 first to start. So 50 plus 29.6 is 79.6. This is the way that makes the most sense to me. All right. Now we're going to add 6 to this. So we're going to add 6 more. And 79.6 plus 6. This is the part I'm doing in my head. 6, because you always want to have it match up. There's your 5, 85.6. But in my head, I just did 9 plus 6 is 15. And then finally, we have to add the 0.6. And 0.6 and 0.6 is 0.12. So I got to go up one. So it's going to be 86.2. Ta-da! Oh, I didn't write on the bottom. Sorry. 86.2. All right, let's see what the next one have in store for us. Sweet. Look at that. I like this way to go to the whole number. So add 0.4 to make it 30, add 50 to make it 80, then add 6 to make it 86. I like this. I like the backtrack too. That's fun. But this is the way I keep doing it. So those are the 3 ways. All right, let's see what else we got. All right, so now we get to do this with an algorithm. So at first we did base 10 blocks. Then we did decimal addition, and now we're going to do an addition algorithm. So let's try it. Let's get some more space. So let's see what this algorithm looks like. Follow the steps to guide you through following the addition problem, 64 plus 73. First, write the 2 add-ins, the numbers being added, 1 on the top. Okay, so we have to, so remember, here's a new word, add-ins. So those are numbers being added. Cool. All right, so they want us to put them in here. 6, 4, 7, 3. All right. Well, they add the units. 3 plus 4 is 7. Cool. Nice. 6 plus 7 is 13. Sweet. Correct. Yes. We did it right. So this is the way that I always add. But I'm trying to show you every way. So the algorithm is the way that I always do it. So let's do another one. Now we're doing it. Another one. Oh, this is without the guided part. So let's put them in. So here's 13 and 58. Next. Oops, sorry. So 3 plus 8 is 11. So we carry the 1. Next. And then 1 plus 1 plus 5 is 7. So I'm going to go tab. It's just 71. Yes, we got it right. Cool. All right, let's keep on going. So we get to go to 3-digit numbers. All right, so we have 775 plus 33. So 775 plus blank 33. Well, 5 plus 3 is 8. Then we have 7 plus 3, which is 10. That's a 0 here. Carry the 1. And 1 plus 7 is 8. 808. Nice. Cool. All right, so let's do another one with 3-digit numbers. All right, so we have 264 plus 238, which is 12, carry the 1. Oops. Which is 10, carry, 10, so 0, carry the 1. And this is 5. 502. Look at us go. All right, what's the next one? All right, so now you've got ones with missing digits. Whew. All right, so our whole goal is to make this harder for students, right? This is like the open middle, all that stuff I was telling you about. So we're missing a bunch of stuff. So we have to figure out, we've got 9, 2, blank, plus blank, 2, 5, equals 1, 8, blank, 1. So how are we going to put these in? Well, this has got to be 11 because there's a 1 here and we're adding. So this has got to be a 6. So there's my 6. Which makes us have to carry the 1. Then there's our 5. 2 plus 2 is 5. 4 plus 1 is 5, which is great. So we have these two. Now, 9 plus nothing gives us 8 because it's too big. So 9 plus what gives us 18? Well, there's another 9 right there. And we got the final answer. 926 plus 925 is 1851. Please use these for your students. Give them missing digits. It will help a lot. We got it. Cool. All right, what's the next one? All right, we got a multi-digit number. Ooh, fun, fun, fun. All right, let's keep going down. All right, so here we go. We got 5181, 9266. There's 7. There's nothing here. All right, 0. This is 14, carry the 1. This is 4. Nothing here. This is 14. Boom! Look at that, 1447, beautifully done. All right, so now we've got the big numbers with missing digits. Let's get into it. All right, so 1 plus 0 is 1. 7 plus what is 5? So we really have to think. We know there's got to be a 15 here, so we know there's a 1 here. 7 plus 8 is 15. 6 plus 3 is 9, plus 1 is 10, so that's a 0. Carry the 1. And what number here added to these two gives us that? It's got to be the 5. Because 5, 6, 7. Magic! There's our beautiful check mark. All right. So now we're on to 2-digit with decimals, and we're going to keep on trucking. So here we go. First, write the 2 add-ins. Okay, so let's do it. I believe it's 92.79. All right, let's add these decimals this way. These are zeros because they don't give us anything. 9 plus 2 is 11. There's 1. Carry the 1. 1 plus 9 is 10, plus 7 is 17. That's a 7. Carry the 1. And there's our decimal place. And this is just going to be a 1. Let's go with it. I'm sure. We got it right. Beautiful. All right. So here we go. We got some 2-digit decimals, and we're going to make it to fractions. It'll be just as crazy when we start multiplying, dividing decimals, it'll get crazy. So here we go. 8. Oh, sorry about that. All right, here we go. 8.6. Oh, my bad already. We got to have them line up. So I need the decimals in the same place. So I can write over here. So if I have 8.6 plus 0.75, I need a 0 here. That way they can all match up. So I need 4 places. 8.60, and this one's going to be 0.75. Now it's all lined up and pretty. 0 plus 5 is 5. Nothing up there. That's 13. Whoa, 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 whoa. Back. I need my 1 up here. There we go. There's my decimal. And here's my number 9. 9.35 should be the answer. Yes. We got it right. All right. We're up to 3 digits. All right, so I'm gonna write it out again. 12.4 plus 0.733. So I need is 2 zeros here. I already know the answer is 3, 3, 11. You carry the 1, 3. So it's 13.133. But have this be nice and neat for your students. 12.400. And then it's going to be decimal 733. You could have them put zeros here if you want. They're not needed, but if you like it, you can put them there. 0 plus 3 is 3. There's our 3. 0 plus 3 is 3. There's our 3. Here's our 11. So it's 1, 1. There's our decimal. 1 plus 2 plus 0 is 3. There's my 3. And 1 plus 0 is 1. And it matches. Cool. Magic. All right, let's keep on trucking. We're almost towards the end of the adding and subtracting one. So let's keep it going. All right, so now we're doing this. Oh, it's the same thing, but it's not guided. So this is 4.19 plus 6.84. 9 plus 4 is 13. That's 10. We're going to get 11.03. So here we go. 4.19. This is 6.84. That's 13. Carry the 1. That is 10. Carry the 1. Oh, carry the 1. There's your decimal. And here's your 11. And that's how you can show your students a really good way to add the decimals. All right. It's the last one of these algorithms, and then we're going to another type of number line. Woo! Here's a big one. Okay. 1 decimal, 1 decimal, 1 decimal, 1. They all have 1 decimal. So since they all have 1 decimal, right away, I know I have a decimal here with 3 numbers, so it's going to be 483.8. So this is where I start. 483.8. The next one's going to be not a cube. 890.6. 195.4. And if these are hard, you can try some yourself. 600.7. Beautiful. All right. That's 10. 6 and 4 is 10. That's how I always do it. 8 and 7 is 15. So there's a 5, and we are at 25. There's my decimal. 5 and 8 plus 2 is 10. Carry the 1. All right, so this is 10 and 17 is 27. And finally, we have 10, 20, 10, 21. So I got 21. 2,170.5. Yes. Cool. All right, so looks nice. All right, so let's change this up. So these were all ways, right? We did base 10 blocks. We did open number lines. We did the algorithms. And now we're going to do adding on a number line. So let's go with it. The number, all right, so I'm going to teach you some stuff about the number line. So here's your number line. Now, I always have a 0 here. Just remember, if it's a closed dot, it's going to be one of these guys, greater than or less than or equal to. If it's an open dot, it'll look like that. And as long as you have X on the left, it's always going to point the direction you want it to go. Isn't that nice? So here we go. Find the result graphically. So a -8 plus 6. So that's going to be a -2. And there it is, -2. Oh, did I drag it? Oh, nice. Well, it's just the dot. Oh, I guess that's what I do. Okay. Find the result graphically. Click and drag the arrows to represent each term. Ah, sorry. So I got to start over. So here's your -8. Oh, this is an interesting way to do it. There's -8. And then we have to do, here is +6. Oh, sorry, +6. And where do we end up with? -2. That's a really good way to show it. So we go left 8, right 6. We're ending up at -2. Nice. I like it. All right, let's try another one. All right, so let's do a harder one. Here's a level 2 problem. So 6 plus 4, and then we're adding a -6. So ready? Here's a +6. And then we have to go +4. So we're at 10, and then we have to go 6 back. Ta-da! What else am I supposed to do? There's the answer. Your answer is +4 because these two cancel. All right, I guess they want me to go 6 here. They want me to go 4 here. And they want me to go -6 here. I don't like this. All right, well, maybe there's 3 parts. So here's 6, there's 4, there's -6. All right, let's see the solution. Oh, I had to show all 3 ways. Sorry about that. They wanted to see all 3 ways to do it. So let's do a new problem. Show question. Here we go. So here's one way. So +4, -5, -2, and sorry, minus. So +4, -5, and then we got to add 2. 1, 2. All right, cool. So then we can do -5, and we could do +4, then we can do minus. Oh, wait. I added 2 instead of subtracted 2. Sorry about that. I got confused. So add 4, subtract 5, subtract 2. Every answer is going to be -3. So now we're going to do what? We're going to subtract 5, add 4, and subtract 2. Showing all the different ways I think is useful. Then we're going to subtract 2, add 4, and subtract 5. Oh, subtract 5. How come I only got -1? Subtract 2. Oh, because I added there. Sorry. So subtract 2 first. Add 4. Subtract 2. My bad. I'm having a moment. Add 4. Subtract 5. And here we go. All of them should be -3. My bad. When it was 3 at once, it just got me. But there we go. All right. Let's keep going with this. Positive and so this one's just without a number line, but we're doing positive and negative integers now. Oh, we get it. All right, we get to do a times 1. These are fun. -9 and -6 is -15. -3 and -6 is -9. -9 and +5 is -4. -8, -6 is -14. 1 and -5 is -4. 6 and -3 is +3. -7 and 2 is -5. -1 and 5 is -6. 9 and -2 is +7. -5 and -1 is -6. 9 and -4 is 5. Oh, sorry. We already did 10. So basically we can stop it, or look what happens when I get one wrong. Oh no. Then you have to try to do your best time. That's all you do for this one. All right. Here we go. Use addition to rewrite the subtraction up below without changing the addition. All right, so use addition to rewrite the subtraction expression below without changing the digits. Do not solve. All right, so how can we use addition to rewrite this? I would do -9 plus 1. Means the same thing, but now it's the other way around. Nice. So subtraction is the same thing as adding the opposite, -9 plus 1. Ta-da! We got it. This is a really hard thing to think about. And so I'll do another problem. So let's do a new problem. So -12 minus a -4. So this is the same thing as -12 plus 4. I always show my students when it's a -12 minus a -4 that they can take this and just make it a positive. And the same thing here. Cool. All right, let's try another one. All right, so now we have a no number line. Oof. So adding a negative is the same thing as subtracting it. So 9 minus 4, we're going to get 5 here. Team positive is 9. Team negative is 4. Positive win by 5 points. I say this up all the time. Act like it's a game. The 9's bigger. That's why we know we're positive win by 5. I like that. Oh, we got another 1. All right, so we got -9, +4, -3, -7, +3, 2, -4 plus 7 is 3. Here we go, 5. Oops, -5, 2, and -3. Stop. I beat my best time. So see, like you can try to beat your time as you go through it. All right. Now we get into the world of action fractions. So for adding fractions, the best way to think about it is make common denominators. That's all we're going to need to do is make some common denominators. So let's go with it. All right, evaluate the expression below and write it as the fraction simplest form. So here we go. Finally getting some real sorts of problems here. 7/10 minus 3/8. You can multiply both. You can teach your students that there's one way to do it. So one way to do it, we can multiply this by 8, this by 8, this by 10, this by 10. So we have 80s on the bottom. So I have 56 over 80 minus 30 over 80, which is going to give me, remember, subtract the top, keep the bottom. So we've got 26 over 80. We can divide by 2. And we're going to be left with 13 over 40. Now, there's a faster way to do it because we have 7/10 minus 3/8. If you knew that their least common multiple was 40, this would be times 4. This is times 5. So this is times 4. This is times 5. It's really going to be 28 over 40 minus 15 over 40. Either way, we're left with 13 over 40. That's the best way to show it, in my opinion. So 13 divided by 40. We got it. Oh, so they did use least common multiples. Nice. Nice. Or you can do the long way and divide first. Either way, you can get the same answer. All right, so there was a fraction. Let's see what else we got. Hopefully some more fractions. All right, so here's some subtractions, is adding the opposite. Oh, so those were all of the addition. The other additions were like polynomials and things like that where I guess I'd go into it when we hit algebra, but I was like, this is enough adding. So it's like the same amount of stuff. We're going to basically do everything again, but with subtraction. I don't know why subtraction is so hard for folks, but let's try it. So here we go. Oh, wait, is the first one has... yeah, the first one is, guess what? Mixed numbers. So here we go. -5 and 4/5 minus a minus 7 and 1/5. So the first thing I would do is I'm going to change these into improper fractions. So you always multiply the bottom and add the top. -5 plus 5 is -25. -20, oh, well, we can just leave the minus for the end. So this is 25 plus 4. So this is really -29 over 5. 25 plus 4 is 29. Same thing here. Multiply the bottom at the top. 7 times 5 is 35 plus 1 is 36. So we're going to be minusing a minus 36 over 5. Two minuses make a what? A plus sign. So all we have to do is the positives more. They outweigh it. So this is your answer, 7/5. If you want to change it, it's going to be 1 and 2/5. How did I do that? Well, I just divided. I took the big number, put it here. Big number is always in the house. 5 goes into 7 one time. What's your remainder? 1 and 2. There's where the bottom goes, 1 and 2/5. Oh, they just want us, that's why. They just want us to write it. So we add the opposite. So it's just -5 and 4/5 plus 7 and 1/5. So I gave you the whole answer. My bad. But now you know. All right, let's keep it going. What's the next one? Ooh, level 2. Might as well solve this one too. Okay, so this one's a little trickier. So it's 2 and 5/6 minus 3 and 3/5. So we're adding the opposite. Doesn't really change anything, right? It's the same sort of problem. So what's another way of writing it? We can switch it around. So 2 and 5/6 minus 3 and 3/5. This is your negative. So -3 and 3/5 plus 2 and 5/6. The reason why this one I won't do is because not only do you have to mix numbers, but then you have to get the bottoms the same and then work it out. So this is your answer. -3 and 3/5. Oh, wait, no, it's just plus. -3 and 3/5. Here it is. If you want to see it, I might as well show it, right? So here we go. Oh, I should change the color. Sorry about the fireworks. 4th of July was yesterday. -15 plus 3 is 18/5. This is going to be 12 plus, so it's times, then add. 12 plus 5 is 17/6. We have to make the same denominator, so I got to times it by 6, times this by 5. So there's 30s on the bottoms. 18 times 6. Well, that's 48. Carry the 4. 6 times 1 is 6 plus 4 is 104. Oh, sorry, 108. And then this one's going to be 17 times 5. So there's 35. Carry the 3. 5 plus 3 is 8. So that's 85 30s. And then this one's negative and this one's positive. So we know we have a negative answer. So it's just 108. Just need a little more space. So it's the minus here. So it's 108 minus 85. That's a 3. 10 minus 8 is 20. So we have a -23 over 30. And that's in simplest form. Look at that. That's the answer. All right, let's keep it going. More subtractions. Subtractions of fractions. Sweet. So anytime you got to subtract these things, you just have to, that was subtraction, but this is addition, which is fine. You just 12 over 19 plus 11 over 19. You keep the denominator. 1 plus 2 is 3. 1 plus 1 is 2. 23 over 19. We can make it a mixed number, but since they say they want a fraction in simplest form, I'm assuming it's improper. Nice. Oh, it's add and subtract fractions. That's why. Whatever works. All right, let's do a level 2. All right, so now I got -4/15 minus 1/6. So they're both minus, so it's just going to be more of a minus number, but I can't minus them until their denominators match. If I multiply this by 2, I get a 30 on the bottom. If I multiply this by 5, I get a 30 on the bottom. So times 2 So this is negative 8/30 minus 5/30. So put them together, that's negative 13/30. Now you might think that 3 goes into both. Here's a good numeracy trick you can teach your students. 2 plus 7 is 9. So, and 3 goes into 9. So guess what? 3 goes into 27. 1 plus 3 is 4. That doesn't go in. 3 doesn't go into 4, so we can't divide top and bottom by 3. You do it by 30 because 3 plus 0 is, as long as it's a multiple of 3, when you add up the digits, 3 will go in. So it's negative 13 over 30. Ta-da! So fancy. All right. All right, so now we got some mixed numbers going on. So here's your mixed numbers. 4 1/2 minus 2 3/10. I can't subtract them because the bottoms aren't the same. 4 times 2 is 8 plus 1. So it's always multiply the bottom, add the top. So 8 plus 1, so that's 9/2 minus 2 times 10 is 20 plus the 3, so that's 23/10. Now, these don't match, right? So I can make this one out of 10 though by multiplying this by 5. So we are left with 45/10 minus 23/10. 5 minus 3 is 2. 4 minus 2 is 2 over 10. So once you're here, 22 divided by 10, you make your fraction bar. Top number special goes inside the house. 10 can't go into 2, but 10 can go into 22 how many times? 2 times. And what's the remainder? 2 2/10, which is really 2 1/5. Whoa, sorry, I don't know why it freaked out. 2 2/10, which equals to 2 1/5, because you can divide top and bottom by 2. That's the answer. Well, I think that's the answer. Let's see. I could always be wrong. Sweet. So there's the first improper fraction. We can show additional steps. Fancy, fancy. Show additional steps. Fancy, fancy. 11/5. Ooh, they broke it this way. I did not do that way. They made the 22 over 10 by dividing by 2 first. This is what they did. So they made this 11 over 5. I just started there. Same thing though. We got the same answer. Beauty of math. All right, let's see what else we got. Oh, I guess I do have some binomials in there. Oh, and scientific notation. Crazy. So we're up to, all right, here we go. So I know this one's long, but it's the first one. So I was like, you want to see everything, right? You want to be an elementary teacher, you got to know all the different ways you can do these. So 4 7/8 minus 1 1/2. So the first step we want to do is change this into a mixed number. 4 times 8 is 32, plus 7 is going to be 39/8. 1 times 2 is 2, plus 1, so that's minus 3/2. So notice that right away I got an 8 and a 2. So instead of multiplying both of these, I'm just going to multiply this one by 4 so they match. So it's really 39/8 minus 12/8. And 39/8 minus 12/8, well, 9 minus 2 is 7. So it's 27/8. I'm just going to go right to dividing it and simplifying it. So let's put the 27 here. Let's put the 8 here. 8 goes into 27 3 times. That's 24. Because 3 times 8 is 24. And there's 3 left over. 3 3/8. You can't break it down anymore. 3 and 3/8. Let's see if that was a correct moves. We did it. We did it. Looks just like my, oh, they simplified this guy. That's okay. They can do whatever fancy moves they want. Either way, we're left with the same answer. All right. I also put scientific notation in here for your add subtract, but that's cool. So let's keep it going. Let's go hit back. All right, so these are what's called binomials. Binomial means you got two things, two terms. So you see how this is 9x minus 6? And this represents the sum. Sum's adding a negative 9x plus 4. So all we have to do is put these like terms together. If I have 9x's and negative 9x's, and I subtract them, they're all going to cancel. So I'm just left with negative 6 plus 4. So my final answer is just going to be a minus 2. And that's it. Ta-da! They put the 9x's together. They're combining like terms. 0x, we never have to write the 0x because it's 0 times x, which goes away. We're left with negative 2. When I got a one-step equation for us. I know it's a little bit of algebra, but might as well. So here we go. Negative 1 equals c minus 4. Our whole job is just to get this thing alone. So we're going to add the 4 to both sides. So that's the opposite. Our whole goal is to get c by itself. So c equals 3. But we're going to write it this way. In case it's an inequality, you always want the letter on the left side. See, they have it right here. C is 3. Here are your beautiful steps. All right, here's some scientific notation for us. Beautiful. All right. Scientific notation. Might as well share. All right, so what does scientific notation really mean? That means just we've got a number like 2.37. So as long as there's one digit in the front. Now, if it's times 10 to the 5th, that's a big number. And we'll do to the negative 5th. Basically, all you have to do is count. And now I always do it this way. Whoa, get out of here, ruler. All right, I always just count them. So ready? So we have 2.37, and then I just take it for a walk. 1, 2, 3, 4, 5. So that's the answer, 237,000. Ta-da! This is minus 5, so 2.37. Now I got to walk it back because it's small, because that's negative, right? So 1, 2, 3, 4, 5. Dot 1, 2, 3, 4. So your answer is 0.000237. All right, so let's look at ours. I don't know what happened there. Made a weird text box. Let's get rid of it. All right, cool. So we have 7.7 times 10 to the third minus 5,400. So 7.7 times, basically it's 7.7. I'll show you how I would do this. It's times 10 to the third, right? So we just got to go 1, 2, 3. So we have 7,700 minus 5,400, 0, 0, 3, 2, 2,300. But to make it scientific notation, we have to count 1, 2, 3. So it's 2.3. There's where the dot goes. 1, 2, 3 times 10 to the third. And there's your final answer. Magic. All right, let's see what the next one has in store for us. Now we get to add and subtract. Oh, we got a level 2, a toughie. All right, so here we go. 2.28 times 10 to the negative 2 plus 0.00502. So the first thing is your 2.28. Got to move it over one place, two place. So it's we got 0.0228. We want to add 00502. So I need how many more zeros? That's 0. There we go. There we go. I need one more 0. 0 plus 2 is 2. 8 plus 0 is 8. 2 plus 5 is 7. 2 plus 0 is 2. So here we go. There's your answer. We just got to make it scientific notation. So we're just going to go for a count. We have to have the decimal here. So we're just moving it over how many places? Once, twice. One place, two place. Because it'd be negative. So we have 2.782 times 10 to the negative 2. .782. So why scientific notation? It's because when we have really big or really small numbers that we're working with in science, we always want to have one digit. It just helps us to clarify everything that's going on and see them. Otherwise, if we've got thousands of zeros, we'll never be able to actually see what we're doing with the math. And that's the reason why we have it. All right, I can see the bottom. All right, so here we go. Some more subtraction. Now we're using the number line. I guess these aren't in the best order, but why not? We could always move them around afterwards. So here we go. 83 minus 36. So the first thing I want to do is I'm going to subtract 30, right? Oh, not 40, 30. 83 minus 36. So what's 83 minus 30? That is a 53. Okay. Woo! So I already got rid of 30. Now I just have to minus 6 more. And what is 53 minus 6? I believe that is 47. Woo! And we're good to go. There's your final answer, 47. Using the number line to show some subtraction. Nice. I still like this way, minus the 3 to get to 50. That's cool. And there's the backtrack. Those are the 3 ways you can teach them how to subtract. All right, let's see what's next on our docket. All right, 3-digit subtraction. Whoa. All right, so first thing I want to do is take away 400. So what's minus 400? And 600 minus 400, that's 275. Let's try that. Nice big old jump. Cool. So I got rid of the 400. Now I got to get rid of 50. So let's get rid of 50. And 275 minus 50 is 225. All right, so I already got rid of the 400 and the 50. Now I just got to get rid of 7 more. And what is 225 minus 7? Well, I believe that is 218. And we will see. Doop. Okay, let's see if that's right. 218. Nice, we did it. We did it. Minus 5 to get to 670, minus 7 to get to 600, minus 300, minus 80. Ooh, so many steps. All right, let's keep on trucking. All right, so now we're up to, whoa, now we're up to, I think we just did this one. No, we didn't do this one. Did we do this one? We didn't do this one. Did we do this one? Oh, we didn't do this one. I must have just clicked down. This is the one we just did. Okay, good. So we just did the 3-digit numbers on the number line. Now let's do decimal subtraction with a number line set up by hand like we were doing it. Okay, so cool. This one looks crazy. 0.073 minus 0.056. So they're starting here, which is kind of crazy. I want to start on the other one. All right, so I might as well do it by hand first. 0.073 minus 0.056. That's 13, that's 7. So our answer is to be 0.017. All right, but can I go backwards? I could always add the opposite. All right, so, okay. So if we have 0.056, and we want to take away stuff. So what's another way of writing this? We can write a negative 0.056 plus 0.073. That's one way to do it, but we have a positive 0.056. So the first thing I'm going to do, I'm just going to subtract 0.004. Oh, that was invalid. So let's see what we're supposed to do for this one. Count 0.00. Oh, we have to count the difference to get there. Oh, that is crazy. Okay, so let's do that again. Making this hard. I want to show the question, new problem. All right, here we go. Now let's make it hard. Well, we can start easy and then we'll do a hard one. All right, so we have to make the 7.5. So the first thing I'm going to do is I'm going to add 0.2, and that brings me to 5. Because we're going opposite. All right, so I landed at 5. So I counted 0.2. So 4.8 brought me to 5. I got to bring it here. So now I got to get 2 more. So I'm going to add 2. And it's going to bring me to 7. Boom. And then I got to add 0.5 more. It's going to move to 7.5. Nice. So we just have to do the amount we counted. How much did we count total? 2.7 is the answer. This is really tricky for me. All right, we're going to do this again. New problem. All right, here we go. So I got to go from 0.35 to 0.51. First thing I want to do is I want to get this to, well, we'll do a little bit of time. So why don't we start with 0.05? This brings us to 0.40. This is the little way. That's why that little way works good. Sweet. So we landed at 0.4, but we have to go to 0.5. So let's add an entire one more. Want a whole one more. 0.1 brings me to 0.5. Now I'm going to add a little bit, just a 0.01. And here we go. 0.051 is where we're supposed to end at. And then we could just add the little bits we have. Oh, I put them in the wrong place. Sorry. So what's the answer? 0.16. A very interesting way to subtract. I've never seen this before, and I like it a lot. Really cool way to show your students how to subtract. All of them are good. The little bits, like I did, the whole bits, and then the little bits, or going too far and back. Let's see what else we got. Oh, we got a level 2. Let's get crazy. I got to go from 27.9 to 31.6. I'm just going to add the point. Let's add 4 first. Why not? And then go backwards for once. 31.9. Overshoot. I've never done the overshoot. Now we have to subtract. What is it? 0.03? Oh, and just 0.3. 31.6. That's the fancy way that they do it. Nice. So we have 4, count it back, 0.3, answer is 3.7. Now I showed you every way to use the number line. Nice. I did one of the ones where you go back. These are fun. All right, cool. Now we have, choose distance or removal as a way to solve the problem. I'd like to use, I'll try them both. Let's do distance first. Oh, wait, we just did distance. So let's do removal. I'm not going to do the same thing a million times. Okay. Yeah. So we did distance before. We might as well do this one. So let's subtract. We have 718. We've got to get to 669. So normally I'd start with this, but let's start with the hundredths. Let's go back and forth since we have that power. So this brings us back to 618. just to start. Then I could add. Whoa. And now I have to add, to get here, I got to add 1. That brings me to 619. And now we got to add 60 more. And that should bring me to the 669. That is not the correct value for where you add. Oh, oops. Yeah, you're right. Because we are at 619 already, so I only have to add 50 to get to 699. Oh, I see what it is. Okay, so 718 minus 669. I was trying to go the other way, but we're not doing distance, we're just removal. So what's the first thing we have to remove? 600. So 718 minus 600 is going to be 118. Ta-da! All right, so I got rid of 600. Let's get rid of 60. That's minus 60. So I did the 100th place. Now I'm doing the 10th place. The 118 minus 60 is going to be 58, I'm pretty sure. And now I just have to take away. So I got rid of 660. Let's get rid of 9 more. 58 minus 9 is 49 is the correct answer. We did it. Nice. Okay, so that was the distance way that I was trying to do. And there's the subtraction way. All right, open number line. So choose, what's the removal? I like the removal way, why not? So now we've got decimals, we're doing the same thing. The first thing I'm gonna do is I'm gonna take away 0.700, 0.7, so 7/10, right? So it's in this place. So I'm gonna take away that, and so if I do 9 minus 7, I'm just gonna get 0.293. Boom. All right, so I got rid of the 0.7. Now I have to get rid of the 0.4. So it's the 0.04. That's the next place. So it's basically just 29 minus 4. So this is going to be 0.253. .29 minus 0.4. Well, let's look at it. 0.993 minus 0.749. Well, that's the final answer. So the first thing I did was, okay, let's just move over. 0.99. I don't know why it keeps this. I gotta reload the page, I guess. Oh, it's not letting me draw. I'm reloading the page. All right, here we go. You lost one. Sorry. Let's try this again. So I have 0.993. I have to subtract 0.749. So I'm gonna try to subtract 0.700 from this. Then I'm gonna try to subtract 0.04 from this. Then I'm gonna try to subtract 0.009. this is going to be the way that I'm going to take away from this. So the first thing I did was minus 0.700. I have a 3, a 9, and a 2. So I have 0.293, and I want a minus 0.040, and that's going to be 3.253, even though they said this was wrong. Oh, I didn't select the minus sign. Oh my God. Thought I made a mistake. And then finally, we're going to subtract the 0.009 from this. So we have minus point, oh my God, minus 0.009. So that's 4, 3, so that's 4.244. So we're going to subtract 0.009 because that's the last piece. We're left with 0.244. That's the answer. Got it. I got it. Yay. Oh, and here's the if you wanted to go the distance way. You have both choices available to you, but I did the distance twice before, so I was like, might as well show the other one. All right, so here we go. 2-digit numbers, guided. Nice, easy one. So 74. So here's the other way to do it, 25. So this was the algorithm way. Can you subtract 5 from 4? No, we can't, sadly. So what number does 7 represent? 7 represents 70. I agree with you. Okay, so 70, we're going to regroup by shifting one of the digits. So 70 is really 60 plus 10. Nice. So we're borrowing here. We can borrow as many tens as we want, but we only need one. I agree. Please click 7. Oh, sorry, I gotta click you. My bad. Yeah, we borrowed it. Okay. We can pay it back. Oh, so I gotta add the 1 here to pay it back. All right, we haven't really changed the problem here. We just regrouped it, which best shows what we did. 7 equals 6. No, that's not really what we did. We did 74 is 60 plus 14. Nice. So what is 14 minus 5? That's going to be our 9. And what is 6 minus 2? That's going to be our 4. So our answer should be 49. Yeah. I really liked all the steps there. I thought it was great. All right, let's do another one. So here we go, 82 and 46. I'm assuming this isn't the one that has the all the little steps, but if it does, that's cool. No, we don't. So we got to borrow the 8 and we pay back the 12. So there's 6. That's 36, our answer. Nice. We got it. It's a really impressive way to show it. This website never ceases to amaze me. All right, now we go 3 digits using the algorithm. So it's going to be the same idea, I'm assuming. Yep. 501, 381. Yeah, we can subtract 1 from 1. Crazy? No, we can't. 5 represents 500. So it's really going to be 400 plus 100. So we have to click this and we borrow. And then we pay back this, so that becomes 100. So 501 equals 4 plus, no, that's not right. 501 equals 400 plus 101. There's the answer. 10 minus 8 is 2. And 4 minus 3 is 1. There's your final answer, 120. Got it. Nice, nice 3-digit subtraction for us. All right, so now we're just going to do a regular one. 901 minus 195. We got to borrow. We got to double borrow, so we got to borrow from the 9. Yeah. And then we got to pay back here. All right, so that's 6. That's 0 because we double borrowed. And there's our 7. 706 is the correct answer. Sweet, and here's all the stuff. So you had to borrow, since this was 0, we had nothing to take it from, so we had to borrow from the 9, make that an 8, and that 10 becomes a 9. And that's how it works. All right, it looks like we got 2 to go. All right, a number line. So let's plot these guys. So plot -9. There's -9 and -4 on the number line. Okay. And find the distance is 1, 2, 3, 4, 5. 5 units. Let's see how we did. -9 is less than -4 because -9 is further to the left. As a result, -9 minus a -4 is a negative number. And the answer is -5. Let's do one more just for the fun of it. All right, so let's put 10, sorry, -10 and 10 together. Cool. Find the distance from 10 to -10. I believe that's 20 spaces. Nice. So 10 is greater than -10 because 10 is further to the right, and 10 minus 10 is going to be, well, it's neither. It's not positive nor negative. So it's 0. Are you sure? So 10 is greater than -10 because 10 is further to the right. As a result, 10, oh, wait. Thank you for stopping me. Because 2 minuses make a plus, and this is 20 whole units. It's not going to be 0. So this is going to be a positive number of 20. I almost made a mistake. We did it! Cool. All right. Finally, here is the last one. I believe, yes, this is our last one to try. Same idea with decimal. So 11.2 is a little bit over the 11. And 4.7 is close to the 5. Oh, I did positive 11.2. Sorry. Oh, it's not going to let me retry it? All right, let's do a new problem. All right, -9.9 is close to the 10. -4.3 is a little bit closer to the 4. Nice. Find the distance between them and click the units when we're done. So I'm not going to use the number line. I feel like that's kind of foolish. So I'm going to go -9.9. So it's a minus. So we just find the distance. So I'm just going to subtract the 2. That's 6. It's 5.6 units. That's my distance. Nice. So -9.9 is less than 4.3 because 9.9 is further to the left. As a result, when we're subtracting it, we get a negative number of 5.6 units. What? That's what I have. I forgot the negative sign. Oh my God, but I wrote negative. Whatever. I'm over it. All right, so that was all the ones I put in the skills for. What was that? All of this was whole numbers. So basically algorithm strategies and models for problem solving for adding and subtracting. I'm going to add into this one the all of the ones for multiplying and dividing. So I'll make another one for multiplying and dividing. And then after that, we're going to go to operations, PEMDAS, and every possible problem they can throw at you. So you'll be ready to go. I hope that was useful. You feel free to try as many as you like. They're in there for you to try, and enjoy your day.